friends, so here we are with another question on KVL and KCL application. So this is the circuit here, okay, and we have been asked to find the value of this current, okay, this current I, okay, we have to find the value of I. And this is the interesting part, the dependent source, that is the voltage dependent voltage source, which is dependent on this voltage drop across the 10 ohm resistor V0. Okay, so let us solve it. So first we will redraw the circuit. So 20 ohm, to V0, then we have 10 ohm minus V0 and this 3 ampere. Okay, this is 3 ampere. Okay, so now let us try to solve it. First, the important thing, the voltage dependent voltage source here, this is the important parameter. Now let us try to figure out how we can solve the circuit. So the way I see it, it will be easier to use the KVL approach to solve this circuit. So here, let's say this is the current I flowing from here, okay. So the same current I will be flowing here, here I, and here also I here, plus minus. Here from this part 3 ampere flows into this side. So current flowing through this 10 ohm resistor will be I minus 3. So here if you notice, this is a super mesh, okay. This, let me use a different color, this dotted path. This is a super mesh, okay, this whole. So we'll apply KVL in this super mesh, and an important relationship here is the voltage drop V0 is equal to 10 into I minus 3. That is very important here, the important equation. So here when we apply KVL in the super mesh, it will be KVL in super mesh. So why it is a super mesh? Because these two meshes have a current source, independent current source in between them, okay. That is the reason why it is a super mesh. So we can also redraw the circuit like this, okay. If we want to have a better understanding, it will be like this. (20 ohm plus minus 2 V0, okay, this is 2 V0, then we have this current source, okay, like this, which is 3 ampere, and then we have the this part, okay, this part. The 10 ohm resistor part, like this. Okay, like this. So like this. So now we have to apply KVL in this loop. Okay. I, here also I, here 3 ampere goes, this is I minus 3, and this is the KVL super mesh here, this. This is the KVL super mesh. So when we write the KVL super mesh equation, polarities should be assigned like we have assigned previously. Plus minus, here it is, plus minus already is there. So it will be 2V0 minus 20I minus 10I minus 3, or we can write V0, then we'll simplify, minus V0. Okay, instead of 10I minus 3, write V0. This is the voltage drop V0, that is equal to 0. That implies V0 minus 20I is equal to 0. Now we'll write V0 is equal to 10I minus 3. Okay, here, this one, this equation we'll use, 10I minus 3. 10I minus 3 minus 20I is equal to 0. That implies 10I minus 30 minus 20I is equal to 0. That implies minus 10I minus 30 is equal to 0. That implies 10I is equal to minus 30. That implies I is equal to minus 3 ampere. So what this thing means, I is equal to minus 3 ampere, it means that the magnitude of this current that we had assumed in the question, that is right, 3 ampere, but the direction is actually wrong. So the actual direction of the current is like this, okay, this is the actual direction, this is for minus 3 ampere. So minus sign only means that the solution is right, only the direction of the current which is given in the question is not right, it is wrong, it is in the opposite direction. Magnitude is right, 3, direction is opposite, that's why the minus sign came in the answer. Okay, I have discussed it many times previously. When you are solving for a particular value of current, and if the value of current comes negative, it means the magnitude is correct, only the direction which you have assumed, that is wrong, it is in the opposite direction. Okay. Hello friends, so here we are with another question on Kirchhoff's law applied to circuits involving dependent sources. So here we have the circuit. This is the dependent source, which is a current dependent current source. It is dependent on this current Ix flowing through 6 ohm resistor. So we have to find the value of this voltage V across this two terminals, okay, which are open circuit. So let us try to solve it. We will first redraw the circuit. So 12 volt, okay, 10 ohm, 1.5 Ix, 6 ohm Ix, 8 ohm. This is what we want to determine. Okay, now, so here this is the current dependent current source, this is the important parameter. Now here 1.5 Ix current is flowing upwards, here to the right Ix current flows, so here to the left obviously 0.5 Ix current will flow, okay, with this polarity, plus minus. Here the polarity will be like this. Here, as it is open circuited, 0 ampere will flow through this open circuited terminal, so the same current Ix will flow through this 8 ohm resistor with this polarity. Another interesting thing is these two loops, closed loops, they are separated. In between them we have this dependent current source. So we know that when two loops, closed loops or meshes, have a current source in between, then it is a super mesh. It is a super mesh. So here we will apply the KVL in this super mesh, that is this. This is the super mesh. This is the super mesh. Okay, we will apply KVL in the super mesh, and that super mesh equation will be like this. (12 plus 10 into 0.5 Ix). Okay, why plus? Because we are moving from minus to plus. Current always flows from plus to minus. Then minus 6 Ix minus 8 Ix is equal to 0. That implies 12 plus 5 Ix minus 14 Ix is equal to 0. That implies 12 minus 9 Ix is equal to 0. That implies Ix is equal to 12 by 9, which is equal to 12 by 9 ampere. And here the value of this voltage V across these two open circuited terminals is basically the voltage drop across this 8 ohm resistor. Current flowing through it is Ix, so V is equal to 8 Ix, which is equal to 8 into 12 by 9, that is equal to, it is coming around to 12, is 96 by 9, which is equal to, it is coming around 10.67 volts. Okay, that. So V is equal to 10.67 volt. That is the value of V. Okay, this is the value. So again, this is a very interesting question because the concept of super mesh come into play. So here you have to have that understanding, that common sense here, that there is a current source, whether it is dependent or independent doesn't matter. If there is a current source in between two closed loops, two mesh, then the whole KVL equation is applied to the super mesh. So here we just put it and got the result. Okay. So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.